Welcome everyone. Today we have our another new episode, and this episode is very important. We will discuss on industrial metaverse. This is our 732 episode, and this is very important because you know that World Talent Economy Forum we are developing industry in emerging economy. So this kind of technology can uplift our community, and especially our audience can learn a lot of new technology and innovations. Dr. Talib Rafal, you are very respectable man for our communities, especially when you run many big organizations around the world. You have lot of integrations with the community, with the policy, with the
Thank you.
politics.
Thank you.
Most Thank you, sir. Most important thing is that now we are in new ways, lot of technology innovating and lot of things happening around the world. So we were discussing on industrial metaverse, but as per my knowledge, I do research on your personal life. I saw that you started your career as a industrialist. You are CEO for a cement factory and many big companies. So how was your journey? What is your experience from the industry and how you implement it in politics?
Thank you so much. Thank you. Thank you, Sharif. I started my work at cement company before it was privatized by the government. The government owned the majority of its shares. Then I was asked to come in and become CEO of that company. That was in 1997 to 1999, or 2000 actually, 3 years. After that, I was in charge of organizing the privatization scheme with Lafarge, which is a cement company in France. Lafarge is a very important company. Now Lafarge decided to keep me as CEO rather than bring somebody from there because I had good relationship with the local community. And I stayed there for 3 years. After that, I became Minister of Planning, then Minister of Information Communication, then Minister of Tourism as well. So that was my stepping stone. The work in the industry was my stepping stone. It was a very good thing for me. I still remember that with very great affection and very great times. Thank you so much.
Thank you. Thank you, Dr. Talib. Now I request Professor David Smith to discuss about industrial metaverse. Professor David Smith.
Sharif, thank you so very much. The industrial metaverse is a very interesting concept today where the current focus when you come to the metaverse is mostly in the world of games, online retail, and social media. But the places where we're going to see some of the biggest payback from the metaverse is in industries that make up really the backbone of our economy and what prepares others for the backbone of our economy, such as manufacture, building, infrastructure, transportation, education, healthcare. These are the areas where I believe the metaverse will see some profound changes in the coming years and creating some real impact. Technology does not exist for its own sake, but technology is to make people's lives better. And you've heard me say that technology is not a thing, but it's the application of knowledge to achieve a result. And that's what the industrial metaverse is all about. The industrial metaverse is a world that's always on, and it's where machines, factories, buildings, cities, all of these are married. The analogs are all married in the virtual world. Second Life was an early stage of trying to get there, but it had its challenges with computing power, bandwidth, and displays and everything else. But in the digital environment, in the metaverse, problems can be found, they can be simulated, they can be looked at with multiple scenarios, they can be analyzed quite a bit, and they can be fixed quickly. Or better yet, you discover problems there before they arise. Another place the metaverse, combined with particularly augmented reality, is going to be fantastic, is in training in real world situations. For example, how to repair a jet engine, how to go and do the elements around that, how to train on very complex systems such as network operating centers and set up for those areas like that. It's also going to be one where innovation can thrive because we can try out new ideas very quickly and very easily. And this should allow us to let our real innovation take off in really great ways. So what the industry metaverse really does is lets us combine the real world and the digital worlds in areas where we can do work together. Uh, Rob in particular, but we always talk about digital twins, and digital twins can be part of the metaverse. Digital twins already combine the real and digital worlds to quicken the planning of factories, buildings, cities, uh, cars, everything. You begin to look around it. And we can improve this entire life cycle as we begin to move this to the industrial metaverse. And we're seeing leaders in there. We're seeing companies like uh, NVIDIA, IBM, Siemens, Meta, and others beginning to really push the envelope on what the industrial metaverse can be. We're seeing a lot of small entrepreneur uh, startups beginning to really spend a lot of time in this. We're seeing the industrial metaverse being applied to how you hold conferences and meetings and training within the real world, how you do remote work. So the industrial metaverse has a lot of potential going forward, and it's one where it's going to continue to change and morph as we go forward. And Dr. Reed, that's probably enough for my intro, and I have a lot more to say, but let's see what Rob has to say, because I always love his comments.
Thank you.
I do too.
Professor Rob.
Thank you.
Well, thank you to both of you. Okay, so industrial metaverse. The predominant player in the industrial metaverse is NVIDIA with their Omniverse product. It was initially created to a large extent to provide a platform to develop autonomous cars, and then it evolved into autonomous robots. And we got the industrial metaverse through this vector, because then it evolved to manufacturing, warehousing, and the places where those robots are done. As Omniverse came up, digital twins were part of its structure, part of its fabric, if you will, and the idea that if you're going to make this work and you're going to have a metaverse, basically you're creating a digital twin, with one of their projects being a digital twin of the world called Earth 2 for weather mapping. That you would have the ability to do more predictive things. In other words, not only just train robotics without putting people in danger, which is always an issue. You've got machines, sometimes very heavy machines, running across the floor, interoperating with human workers. If somebody steps the wrong way or somehow makes a mistake, you could have a flattened worker or worse. So the effort in robotics is always to try to avoid any harm, but the issue is often you've had to train in real time. With the metaverse, you can train at machine speeds, which was very useful for autonomous car development, because you could do decades of on-road trials in minutes, because you're running at machine speeds, not the speed that we typically use in the real world. And that also allowed for simulating almost any kind of an event, even though it may never snow or sleet in parts of the Death Valley. You could still test for that, where in the real world, unless you're going to bring in a snow truck and dump it on the roads there, you wouldn't. Now, I'm not sure you'd want to, but it just showcases that you can test for a wider variety of elements, things that might only occur every 1,000 years. In a metaverse environment, and where in the real world you either have to create it physically or you'd have to wait 1,000 years for the event to occur, which would be problematic. As we just saw with the earthquake in Turkey, these kinds of digital structures can be used to simulate against accurate digital twins and see what the harm or damage would be, so that you can maybe use it to get funding to reinforce buildings, change building codes to make sure that the disaster doesn't occur. As a race and society, we have a nasty habit of not doing really good risk analysis, and what the metaverse, the industrial metaverse, allows you to do is make your argument much more easily. Now, people were always able to, if you had enough money, to create through using animators simulations. But the issue with animation is everything's artificial. With the metaverse, including the industrial metaverse, you can build in physics. And so the end result is things, when they break apart as they would break apart if they were in the real world, as opposed to whatever the artist thought was going to happen when the event would occur. And so it makes the predictive nature of the industrial metaverse potentially much more accurate. And this allows you to do things like BMW did with their latest factory. You design the entire factory in the metaverse first before you ever build any part of it. When NVIDIA did their headquarters building a few years back, as an initial test for the concept, they built the building in the metaverse first. And the interesting thing is what they discovered, because this was a building that was kind of revolutionary in concept. A lot of open plan, a lot of common areas, a lot of areas that are lit by natural light, as it searched for kind of an ideal LEED level of certification. They were able to see that by rotating the building, by adjusting the windows, whatever, they could get the light to react with people better and not cause problems. Because often if you've got, for instance, a solar lit building, you'll have problems with glare, or you may have problems with parts of the building are not adequately lit, and then you've got to light those parts with artificial lights, which kind of takes you away from the idea of having mostly solar light the buildings. So in the end, they were able to optimize the building not only for its lead elements and for its interpersonal elements, but for the appearance and creation of the interior that their CEO wanted. And typically, as I say, when you build a structure, often the structure goes up, whether it's a house or a building, and it's almost done, and somebody comes through and says, "Yeah, it really wasn't what I was imagining." So rip down those walls, move that ceiling, whatever, and it gets expensive when you're doing that with the physical structure. But in the metaverse, it's just changing some code, and so by being able to work through in the metaverse the design of the building, not only can you make it much more robust, you can make it function better. You can better match the client's needs, because as we all know, if anybody's worked with clients, sometimes they don't really know what they want, and that makes it problematic when they're describing what they want. I remember a story that went back to Larry Ellison, the CEO of Oracle, when he was having a house built. In the back of the house, he had a boat that was on rails, kind of like a Disney ride, with that went in and out of the house. You get in the boat, it would go out in the stream. Some people have more money than sense, but we got in the stream and come back. But he was just really unhappy, and the contractor doesn't understand. I built what you asked me to build. He says, "No, it's not right." He says, and then finally goes, "Oh, you want a bed on the boat," for obvious reasons, and then figured out he had to redesign it. Now I know what it's not a boat to ride around in with guests. It's a boat to do something else with, and that allowed him to do it. But a lot of the work had already been done, and that meant redoing it. And when you're building about something like a boat on a rail that's going around and in and out of a house, that can be a pretty expensive change. It might require you to expand the canal. Certainly, you're going to have to redesign the boat itself, and you do that after the thing's been built. That's pricey. But if you can do that in the metaverse, then the client's happy, and the contractor comes in at or under budget, and is more likely to get more business from the client. Because for any of us that's done this kind of work on a home or an office, you know that if you work with an architect and a contractor and it doesn't end well, even though it may be your fault because you didn't articulate your needs, you're probably going to blame them. So in the end, the industrial metaverse allows you to do things that you either wouldn't be able to do timely in the real world, or couldn't do cost effectively in the real world, and better assure the outcome. Now, the final aspect of the metaverse that I think is kind of interesting in using digital twins, it's using it for remote maintenance. So the idea of you have a digital twin, and the digital twin's tied tightly to the equipment that is twinned, you can advance that twinned equipment in time to anticipate critical failures. And then if a failure occurs and you're remote, you can trial the fix in the digital twin before you apply it in real life. Now, we do that a lot of times in code, but we rarely can do that with physical structure. And a lot of things we're exploring right now, like putting data centers underneath the ocean for more effective cooling and power generation, you really wouldn't want to place people down there for long periods of time. It'd be like submariners. It wouldn't be ideal. You'd have to put down recreation. You'd have to handle food, air, and all that other stuff, making it pretty costly. But if you can use robotics and digital twins, it makes it viable. So suddenly with this technology, you can create things that you couldn't create before. And not only talking about underneath the ocean, but exploring the moon, exploring Mars. You do a lot more testing against failure with these artificial constructs, and therefore make better assure that the missions that go to these remote places where they're not going to be able to pick up the phone and call Best Buy to send out a Geek Squad guy to repair their stuff, that's all been anticipated before they got there, and that particular tool they might need, where they can't run down to Home Depot and buy anymore, is already provisioned in their kit. So the mistakes are caught, or the errors are caught before the mission ever begins, thus preventing what could be life-threatening problems once the mission is on the moon or Mars. So heavy use now with regard to space exploration or anything you're doing remotely. So it's a fascinating area. And honestly, if I were starting off in technology now, that would be one of two areas I'd look at. The other would be generative AI, which we've talked about in other sessions. But right now, that looks like where it's got an awful lot of headroom, because we're nowhere near where we're going to be.
Thank you. Dr. Talib Raphael.
Thank you so much. My experience is not that intense. I understood from David and from Rob now what Metaverse is. Now, David stressed technological part, and Rob stressed the artificial intelligence part, the robots and all of that. Now, my experience, we were running a very traditional company. Maybe cement companies is not the best to apply this in, but it should have applied, because I remember once there were people that were cleaning the silos, the silos where we store this thing. They had to physically go bring people inside the silos to clean them up, and some of them got stuck there. I remember going down to try and get them out, because it was a very, very hectic thing. Now, I don't know if that's something that should be applied on cement companies as well. But what I know is the following. What I know is that the cement companies don't apply Metaverse. They don't. Not only in our country, but all over the world. The Lafarge was a cement company, the best in the world. And it didn't have any technological advancement at all. Actually, it did put itself into any trouble. I did mention that they kept me as CEO. They kept me as CEO because I had good relationship with the community. And the factory was emitting so much carbon into the air. And the people around it were very, very unhappy about this. So what happened is that I had to talk to the people there. I had to bring them along. I had to make committees from the local community to try to make them understand what we're doing. Now, this is not an experience that the industrial metaphor will be doing, I'm sure. So that's what I want to say for the time being. Thank you so much.
Thank you, Dr. Talib. Professor David Smith here.
Actually, I love your story there, because one of the consulting projects I had several years ago was actually in the same industry, but with Thai Cemente over in Thailand, and trying to help them begin to see how they can transform that company into a future product set using other materials than traditional concrete. And we began to do quite a bit of digital simulation with them. And then they took and used that same simulation of whether they should move from primarily an Asian-based company into one that actually served your part of the world as well. So the type of things that the industrial metaverse could use, particularly creating the digital twins, is one that can be very beneficial there. Also, if you begin to look at even the process of making concrete with different variations, like what you use in road construction for bridges versus what you do with an airport with concrete, what you do when you're doing construction, particularly in high rises, buildings with it, the formulations and things can be very different. And doing in the metaverse and simulating the metaverse, and even taking the industrial control systems that are varying the mix of the materials and water and everything. There could be a very good application for some of the tools that are used in the
Did
metaverse.
you say? Did
So
you say that factory was in Thailand?
yeah, it was in Thailand. It was Thai Cemente.
Okay.
Um, and they were a major provider of uh, cement for all in Asia, and began to do it some in the Middle East too. But
Yeah.
it's one where the digital part began to get into there. And that what the industrial metaverse also does, and this is where Rob and I are in, I think, some violent agreement as we look at the pervasiveness of the industrial metaverse, is it allows new business models to be used and expanded. And it's places where technology, marketing, executive boardrooms, the workers, every area of the company can come together in the metaverse and work together. And they can do it without leaving their homes, without leaving their desk, without leaving the factory floor in many instances. Um, and you can do it independent of geography. You can create a metaverse that can look the same if I'm in Thailand, Brazil, Jordan, Bangladesh, or Austin, Texas, and we can all interact in the same industrial metaverse, and be able to do it there. And whatever departments in the companies we're in, we can do it. But understand that also one of the big uses of the industrial metaverse is to become customer facing, but we can also move away from that as well. And many of them we can actually use the metaverse to optimize the resources we're using, to reduce our travel requirements, and to reduce the ability to have to do mass training, where we can move more to just in time training or other group training without having to transport people into traditional classrooms, and we can do in the metaverse. And that we're seeing that the metaverse promises to move us from some of the advanced modeling simulation tools we have, some of the digital trend uh, tools we're using, into a concept that's being called the Internet of Experiences. We know, for example, that we have the Internet of Things, where we are connecting a multitude of sensors and other objects into the internet and using them. But the industrial metaverse will allow us to take the whole concept of digital twins, the context of working together in a virtual environment, to a new level. And it's going to be a shift uh, from the Internet of Things to the Internet of Experiences, where we have the interconnection between all the elements, and can do it. It's going to allow us to really create a very dynamic place where we can do, for example, production level simulations. We can do collaborative research and development. We can do mass education, where we can bring some of the best resources, not only the teachers, but the ability to see it in the being used in applications and things. Health, I can just see that the healthcare industry will benefit tremendously. Safety training, smart cities. Smart cities are really the interactions between people, vehicles, facilities, both virtual as well as we go. Great place for the industrial metaverse. Rob mentioned robotics. Robotics is going to be a big area of the industrial metaverse. Not just the traditional manufacturing robots, though, but we're also going to see robots that are going to help people in need. They're going to communicate with assistants. They're going to facilitate access to things like groceries, healthcare, doing tasks around the house, where you can create an environment such as the metaverse and use it to allow your robot to work very effective in it. So it's blending the physical and the digital to create the industrial metaverse, your business will be able to change its operation and look at things in a world that gives you the opportunity to move more rapidly, more efficiently, and try things before you have to do them really in the physical world, where the cost to do those is very expensive. The time to do them is very expensive. Oftentimes, the waste in materials. To try it as a prototype and see it doesn't work, where you can simulate that more easily in the metaverse. Those are all going to be some of the big benefit areas from this industrial metaverse.
Thank you. Professor Rob.
So one of the areas that's not working in the industrial metaverse yet very well is one of the areas that was thought was going to be one of the best parts of it, which was collaboration. The Meta itself focused on that area, as did Microsoft, and you might have noticed, I think it was last week, Microsoft completely collapsed their efforts as they switched pretty much the entire company to focus on generative AI instead, which is kind of interesting because but it showcases that not everything is perfect. It was relatively comparatively easy to create digital twins of equipment. It's proven relatively difficult to create digital twins of people. And when we talk about a collaborative environment, the expectation was that people would walk into this environment and be kind of like the holodeck in Star Trek, where it kind of felt like you were there. But even with some of the leading industrial efforts like Microsoft's on HoloLens, which is kind of an AR construct and then a VR construct, but also works in the metaverse. The issue was once you had the glasses on, you could create an experience for the person wearing the goggles that looked pretty realistic. The only problem is the person on the other end would see the person with the goggles, and that wasn't going to work. And then if you used avatars, the avatars either lacked body parts like legs, or they looked, in fact, generally they looked very cartoony and artificial. And going back to that, the Second Life example that David Smith used early on, that was one of the problems with Second Life is it was too much like an artificial video game. It wasn't real enough. And in some cases, it was just on the wrong side of what we call the uncanny valley, where people just look creepy. They don't look real. In fact, the uncanny valley has been a huge problem for a lot of emulation products that emulate people, because it's very hard to create somebody real time that looks real. We are very able. If you go on the web, you will now find there are a lot of the models that are being used are generated by computer, but they're not generated real time. They're generated and then they're played back real time. And when you're collaborating, it's not like you're going to wait a half second for the other person to render. So right now the performance level we are at doesn't let us to create real time avatars that are good enough for people to accept them in collaboration. That doesn't mean we're not using it for collaboration. We are. You don't have any other choice. Being able to do a collaborative project in the metaverse when people are located all over the world is often better than having to fly them, particularly if you're trying to collaborate with somebody in Ukraine or somebody in an area where travel is restricted, either because of medical reasons or political reasons or whatever. And the end result is you can do things in the metaverse if you can get over the construct that are very similar to what you can do in person, and that does allow it to function. But the frequency is still lower than what's sustaining businesses. You just saw Zoom just had to lay off, I think, 1,200 people because now that we're out of the pandemic, even the tools we've got now aren't being as heavily used as they were during the pandemic, which was certainly predictable. But in the end, this is the one area that we're watching closely because we're approaching it pretty well. I mean, we're close. If you saw one of the NVIDIA presentations, I'm guessing about a year ago, where they miniaturized their CEO, they actually had the expressions on the face were good. The character looked much more realistic, still a little bit on the wrong side of the uncanny valley, but closer than we've ever been. And certainly implying that maybe within 3 to 5 years, we will be able to render real time and create a deep fake level of experience for people in the metaverse. The other issue that's concerning, however, is it's not just visually we need to integrate the people, it's physically as well. And the instrumenting of the human body has been lagging. This is the one area where Facebook, I think, got the problem right, because they started investing heavily in physical instrumentation. But it's unlikely they're going to be able to finish the effort, because they've just been losing money at an unsustainable rate on the project. And now with this hard pivot toward generative AI, you kind of wonder if they're going to be forced to flip their development efforts over to something that represents a far larger threat than the metaverse does, the social metaverse does, an opportunity. But in the end, that's the one area we're struggling with, is how do you do collaboration within the metaverse other than for unique efforts, and how do you make it much more like collaborating in person, and then how do you deal with the problems that products like this have, which is when you're remote, how do you put back in the social elements, how do you put back the side engagements? It's certainly possible with the metaverse construct, certainly more possible than it is with a construct like this, where you've got separate windows. Because if David and I wanted to have a side conversation, we'd either have to do it in private chat, or you'd have to pick up the phone and do it on the side. It would be very difficult for us to do it within the construct of this windowed environment. But in the metaverse, we could just walk into another virtual room and have a chat, and assuming that the privacy elements of the metaverse were intact, we might even be able to do it more privately than we could do it in real life, because you just turn off the inner wall sound. So in the end, there's a tremendous amount of untapped potential in the social metaverse. The technology isn't where it needs to be to make it work yet. And so most of the focus right now is still on simulating physical objects. And when we do simulate people, it's people as an object. In other words, when we're training robots, it's training the robots to avoid a person, but not yet really training them to interact with them tightly, or certainly not training them to having people interact with each other tightly, because we just don't have that level of resolution cooked. And the users are demanding a much higher level of resolution and accuracy than being provided. One benefit, though, if we finally get there, is we can freeze for in the metaverse. You can freeze your age. You could always appear in the metaverse as you did in your 30s. You could show up for an event in your pajamas and look like you're in a suit. And you could even have it so that whoever the audience was, you were dressed appropriately. So if you had a mixed audience that was Asian, European, or whatever, and the traditional dress or whatever was different for each of those societies, each one of them would see you differently. So, for instance, if you were talking a culture where women had to cover their face or their hair, the participant wouldn't need to do any of that. The avatar would do that for them, and so they would be able to maintain whatever the social constructs were, regardless of how they appeared naturally. And it could be different for every one of the regions they broadcast to, things you couldn't possibly do in the real world. So it gives you a lot of potential to do interesting things in terms of working around social constructs. And for instance, even if you wanted to change sexes, there was a problem in some European countries and some Asian countries with men working with women. They just didn't feel that women could contribute, that they were somehow lesser than. Germans might remember this back when GPS navigation came in. They refused to do it because it used a woman's voice and they weren't going to take directions from a woman. That's a true story. So they had a male voice. But a woman could appear as a man. That if they're working in a culture where men aren't appreciating a minority or women, they don't have to know they are. They could appear as a man, or they could appear as not a minority if they so chose. Of course, there are issues with that as well. But it gives you an option that you otherwise wouldn't have. And in the end, it gives you a tremendous amount of flexibility. But you still have to make it realistic enough so that people interact with you. I'm not sure it would do you a lot of good to appear though it would be a lot of fun to suddenly walk into the room as one of the aliens out of the movie Alien. But that would be probably something in my younger life I would have tried, just to scare everybody in the virtual room. But you can have a lot of fun with this. And in the end, you could use it to cover up things that the speaker could be sensitive about. For instance, if you have somebody that is a paraplegic, or has some type of facial disfigurement, you can correct that digitally, and they could appear normal. A lot of people are very sensitive about the way they look, and this is one way to deal with that without requiring them to put on a lot of makeup or certain types of prosthetics to get around the problem, making it much more convenient for the individual and much more conducive to the collaboration by removing distractions, but always up to the user to apply them. Which is perfectly the way it should be. So in the end, the social construct from the metaverse actually proved to be even more interesting than the physical construct, because the one other thing you could do is you could introduce generative AIs, give them avatars, and then over time begin interacting with these constructs as if they were people. And if you've ever worked or spoken to a current generation generative AI, it is really hard to tell they're not a person. And if you get and we're coding in expressions now, emotions, the fact that you could have, and people are exploring this idea of having a lifetime digital companion, or be able to have, for instance, an avatar of a relative that is passed, or a political figure, a great political figure that you might want to learn from, or even you might want to learn from Einstein or something like that. You could create a construct that working from his prolific writing could act and react very similar, if not identical, to what Einstein would do at that time. And that gives a huge opportunity for students to learn from the very people that created the constructs they're learning, and hear from them in their own words, but rather than reading them in a book, actually have them spoken from what appears to be their own mouth. And the interesting thing is we can do a lot of that now, because that doesn't need to be real time. It's just that the animation part of it does. So you're going to see generative AI constructs using voice. In fact, we already are seeing them in market. And the only step is to take those emotional constructs and turn them into and apply them to the avatar to give us somebody to talk to. If everybody's been through the Disney House of Presidents thing from years back, it was pretty interesting to sit there and watch, Lincoln get up and give a portion of his Gettysburg Address. And that was done decades ago. Now we can do it, make it far more realistic, and actually allow him to respond to individual questions and interact with people as if he was there. I think this is going to be as this matures, this is going to be a really amazing way to provide teaching in areas like civics and social constructs of psychology, sociology, the things where interacting with some of the founders of the various aspects of those studies could be incredibly beneficial, and we could learn a lot from it. And not the least of which is things that have been attributed to them that are not true, that would probably point out. For instance, I can picture Marie Antoinette saying, "I never said that they could eat cake," which she never did. So in the end, it could be hugely beneficial in terms of being able to teach. And my hope is at some point, future schools will have sessions where you'll get to talk to the very people that created the subjects that they're studying.
You're talking about artificial intelligence now, right?
Yeah, artificial intelligence as projected into the metaverse. And because it could be an interface between these artificial intelligences and people, allowing them to see these artificial intelligences as if they were people instead of machines, which could significantly increase the interaction between the two elements.
Dr. Talib Rafat, you want to add any points?
Okay, yes, I do. I wish I had heard David and Rob 20 years ago when I was still a CEO in that company, because that company did not apply any of the technological advancements that we had here. We're talking about here. I don't know if the company in Thailand did something similar, but I can say something. This has nothing to do with us being a developing country. It's come from even developed countries. It doesn't. It's a way of thinking. I think in cement companies in particular, people did not think of it that way. They didn't think that they could produce better cement with better digital, better robots as such. We had many people employed in that company. There was 5,000 people working in that company. Now that's a big thing. You have to sacrifice that, of course, if you go into digital economy. But what I wanted to say is, I wish I heard David and Rob at the time, really. Particularly Rob. I truly appreciate what you said, Rob. Thank you so much. Thank you.
Thank you. Thank you. Professor David Smith, I know you have a presentation. Professor David, you have to unmute
Muted.
yourself.
I'm sorry. Yeah, Sharif, I usually talk about market size, and the industrial metaverse is a market to itself, and you begin to see it. ABI Research is one of the market forecasting companies, believes that the industrial metaverse uh, will hit almost $23 billion by 2025. And that one of the big drivers of this industrial metaverse to hit that numbers is the things that we've talked about on prior programs with you, Sharif, with Industry 4.0, with things like what Rob and we've been talking about with AI, machine learning, edge computing, all the different types of augmented reality, even the holographic reality and others, to be able to extend reality to really let us do digital transformation more. If you begin to look, though, with these numbers, they're looking kind of across the three buckets that we see the metaverse being applied in. We see in the first one the consumer metaverse, which is really looking more and more around gaming, other activities like that. Then you begin to see that the revenue shifting, but it's going to around 40 billion US. Then you see the the enterprise metaverse, where it's more of the things like what Rob was talking about there, where there's still challenges like in immersive collaboration, how you begin to provide it, and how do you put business value out of it. And you can see it's growing at a pretty shallow curve going forward. With the industrial metaverse, with digital twin simulation, and how the industrial reality is extended to result in operations, automation, and all the other things that we've been talking about all morning. It's a pretty steep curve going up, and going up to around $100 billion fairly rapidly in this chart by 2030. So
What's
just to
that
help,
chart? What's that chart, David? The last
this
chart
is
is
this is from APA research. It's the one being broadcast right now. But you
okay.
can see the three buckets: the consumer, the enterprise metaverse, and the industrial metaverse. All have
Okay.
different acceptance curves, and they all have different uh, accelerations and eventual market values. And this just underscores to me the impact that the metaverse will have across all these segments. You know, in your prior program on this, Sharif, we talked mainly about the consumer metaverse, a little bit about the enterprise metaverse, and a little bit about the industrial metaverse. But you can see it's the combination of all of these that will drive the metaverse. And the industrial metaverse, which is your topic today, is really the one with the steepest growth curve and with the highest penetration into the marketplace. And uh, you can see that the industrial metaverse, by looking at that curve, is going to be a fairly large inflection point for the industry. Um, and you see, for example, things like the 5G technology we've spoken about on earlier programs being also an enabler to this. All the AI tools, all the visualization tools, all the combining of sensors, not just the Internet of Things sensor, but more sensors across manufacturing, others, the integration of robots. And you'll see robots in the consumer metaverse, you'll see robots in the enterprise metaverse and the industrial metaverse as well. So you'll see those technologies going between all of them. And you're going to see, for example, in the metaverse, you're going to see some of the autonomous drones that we see today, and some of the advanced machine learning capabilities with machine vision tools really come back and play a big part of this, and be working with that. It's going to be difficult, though, to begin to say how the acceptance curve is going to go, because one of the constraints you have in the industrial metaverse is how do you interact with it? How do you um, control the networks? How do you get down to very low latency? How can you get into decentralized edge data centers, which are close to the users? The others is how do I see? It's going to be very difficult for people to carry head virtual reality headsets, 3D headsets to do it. So you're going to be looking at ways to do it on traditional displays. We're going to need to create much leaner and lighter headgears, and looking at how we offload a lot of it to edge computing. We're going to be looking at how holographic displays and others uh, get to become part of this environment. And you're going to see a lot of things is there's going to be a lot of growth in the building blocks of software, the building blocks of displays, the building blocks of advances in networks, and how these can all come together to uh, impact the world and the industry users. Machine vision is going to be a big part of the industrial metaverse, where that you can use machine vision of things happening in the real world and translate those into the virtual world of the industrial metaverse, and be able to have those interactions. I actually look forward to the time where we will see a lot of the digital twin technologies continue to expand in the metaverse, with a closer coupling between things like the advanced machine learning, the advanced natural language processing, uh, and machine vision, others, to create even a tighter integration and a tighter bond between what we can do in the metaverse and what we can do in the real world. And, particularly, though, we need to understand that the metaverse comes with some challenges. And some of them, and I almost sound like a broken record on this, but we need to look at the cybersecurity. We need to look at privacy. We need to look at how do we protect the information? How do we keep bad actors out of our metaverse? If I am running a factory by using the metaverse and doing real world things with it, how can I keep a bad actor from going in and taking control of it? Or if I'm using it for autonomous vehicles, such as autonomous trucking and others, how can I keep bad actors out of it? How can I keep viruses? How can I protect what's there? Those are some of the challenges that still need to be solved as we look at the industrial metaverse. And same thing with some of the regulatory environments. Is banking or health and safety rules, or workplace compliance, all of those regulatory environments that affect the physical world, how are those regulatory environments going to be translated into the metaverse? Uh, you know, it goes back to what we were talking about earlier in the week, Dr. Sharif, even with fintech. How does fintech work in the metaverse as opposed to fintech in the real world? So those are some of the issues that we still have to solve as we are looking at this in the future.
Rana, I think it's your turn.
Looks like
Pick 'em up. And this will be a wrap for me because I go on radio in 8 minutes. One of the interesting things about David's last chart was if you looked at it, you saw the industrial metaverse with a steep increase and and you saw both the consumer and the enterprise metaverse was relatively flat with an increase out around 2024, 26. So I used to do numbers, and the reason I don't do numbers anymore is because because there's a lot of pressure to make these up and to the right charts, and if your chart is flat or down to the right, people won't buy your research, and so the research companies that produce this have learned it, and so you need to learn how to read these charts. And if a chart is flat for a period of time in the future, and then goes up, that going up part is largely wishful thinking, because they don't have a trend to extrapolate. With the industrial metaverse, where it's already going up, they have a trend to extrapolate, and that graph may actually turn out to be fairly accurate. The other two will probably turn out not to be accurate, either underestimating or overestimating significantly the adoption. And that's because they don't really have a trend of adoption yet to extrapolate from. They are assuming it's going to take off in 24, 25, and 26, largely because the vendors that are building this stuff have told them they think it's going to go up in 24, 25, 26 because they're spending all this money on it. But just because you spend money on a product doesn't mean the consumer is going to be there. And my big lesson was when I went into numbers, because I've been buying numbers on the other side when I was an analyst at IBM, was that I wanted to create an accurate forecast. And so in the area that I did, and this was Data Quest, I created what was arguably the most accurate 5-year forecast that they ever created. I predicted the demise of Unix. I predicted the elimination of NetWare, which didn't endear me to the companies that made those products, but turned out to be fairly accurate. And the significant advancement of Windows, which a lot of people in the competitive area disagreed with rather sharply. But we know now that all occurred. So in the end, when you're doing predictive work, just recognize that you do have clients out there. Oh, I should point out, during that 1 year that I did that, I met more CEOs that wanted to fire me in that year than I did the rest of my life. The number of folks that were telling me I was never going to work in the industry again were legion. And of course I'm still here. They're not. But in the end, it was a lesson to me about how to read numbers. And so when you're looking at a chart, you see a long flat area where there's not much market, and then an eventual upswing. That's wishful thinking. That they have no market trend to extrapolate from. But on the other hand, if the market's already starting to ramp, now they've got a trend to extrapolate from, and that extrapolation will probably be relatively accurate. But then also recognize the bias is always going to be to err on the side of being overly optimistic, if I will say. So just recognize you probably have a degree of error there that's going to drop below the line in most cases. Now, back in closing with the industrial metaverse, this is one of the areas that's going to change greatly how a number of industries work. Talib talked about the cement industry. Mining is another area that could make a great use of robotics. Very unsafe for folks, where they don't really use a lot of robotics, largely because the cost of training has been extremely high, and the numbers of people that will buy the robots have been slow, so it's been hard to fund them. But the nice thing about the metaverse is you can get the training costs, and a lot of times with robots that are operating autonomously and even remotely, it's that training cost that raises the overall cost of the solution. If you can do that training in the industrial metaverse, you can lower that cost dramatically, and that makes the equipment more affordable. Sadly, in a lot of areas, it's just cheaper to pay the insurance and the death benefits than it is to buy the automation. I think that's a failure in government. It should really, when you've got a solution that can take the risk out of a particular operation, and that risk is significant, then there should be equally significant government incentives and penalties if you don't use it. So that if you use it, incentives; if you don't use it, penalties. And a lot of governments, I would argue, most don't. So as we come up with these solutions. Oh, by the way, one final thing on that. A lot of times, the very people you're trying to help aren't fans of the automation because this is their jobs. And so the very people you're trying to save are often on the wrong side of the equation, because they legitimately want to preserve their jobs, even though their jobs are unsafe. So you do have some significant issues with regard to implementing them. My experience with silos goes back to farming, and the number of people that would die every year going into farming silos and get buried in forest. It just astounded me when we could easily have done a lot of those jobs years ago with robots, and still didn't, because it was cheaper to pay the death benefits, or you were using illegal aliens, and if they died, so what? It wasn't like they could report you. So the fortunate things are getting fixed to make that a much more painful experience for the managers that do it. But in the end, a lot of the restrictions to using robotics and automation in some of these areas is because it's turned out to be cheaper to take the human risk than it is to use the equipment, which I think is unfortunate. In the end, the industrial metaverse is largely going to be the future of the industry, and as we move it to other areas and evolve it, our capabilities are going to increase, and it's going to make things like going to Mars and going to the moon, and working in areas like deep undersea much more viable than they currently are, and allow us to avoid much of the needless death that occurs when you operate in these unsafe environments. And that's it for me, because I got to go do my radio program. So see y'all next time.
Thank you, thank you, thank you.
Good luck, Rob.
Thank you, Mr. Rob. Dr. Talib, what's your concluding remarks for today's session?
Okay. I think Rob said it all, summed it up in a very good way. I think that the governments must play a role in this, because incentives must be brought into this. Otherwise, it doesn't look very tempting to many people, especially with the number of employees being reduced here. Now, they will be reduced whether we like it or not. Now, some people are saying that the new technologies will need a new workforce, but that's not within the same company. It's in other companies. So I believe that the industrial metaverse will be the future, definitely the future. We need to look at the technology. We need to look at robots as running our industries, whether they're clean or not. Now, some of the industries are not clean enough, like the agricultural industry or the cement companies. But that's I think what made them so slow in adopting the metaverse. Now, these companies have to be encouraged to do that, and governments can give incentives for companies that do that. Now, as a developing country, I believe that the metaverse is good for us, because it does expose us to the latest in the world, latest technologies in the world. But the challenge will always be, as it was before when we talked about technology, the spread of internet, spread of technological equipment, the spread of mobile phones and iPads and computers. That's something that we are struggling with still until now. So that's why we tend to go to companies like the one I used to run, which is a very, very traditional way of running it. Now, what we didn't talk about here also is the effect on the environment, because the effect on the environment in some of these industries, especially the mining industry and the cement and the agricultural industry as well, the effect on the environment is very, very big, because we still use those big high pumps to pump the oxygen into the air, carbon dioxide into the air. That's something that we need to be very careful about. Thank you so much. Thank you.
Thank you. Professor David Smith, what's your concluding remarks for today?
Well, Dr. Sharif, thank you so much for letting me be part of it. I agree with what Rob and Dr. Philippe said, and particularly the industries, because you see the industrial metaverse really has increased demand for performance. It really has to be ultra reliable. The network has to be extremely stable, and advanced cybersecurity needs to be addressed before the industrial metaverse can be utilized fully on a global scale. However, companies today, universities, everything should have the awareness of the industrial metaverse. It's not an experiment anymore. It's an awareness that needs to be accompanied by the right technology, intelligent, autonomous, cloud native networks, high bandwidth, ultra light latency. new visualization approach, new sensors that we'll need there. But we believe that the early users of the industrial metaverse will be focused in some industries, particularly those having physical assets as manufacturing, logistics, transportation, the healthcare industry with metaverse, but particularly in areas such as telemedicine and robotic surgery. And really, the use cases are so infinite that the industrial metaverse can apply to almost any industry. And it's the people that are going to make it happen, the people combined with the digital systems, and they're going to be the drivers. So while much about the industrial metaverse remains unknown, its endless possibilities are really the thing that we can know, and the opportunities it creates for companies, for
Fully agree.
research, for entrepreneurship, for innovation are really tremendous. And that is my really concluding mark is companies today, universities and governments, because governments should take advantage of the events metaverse as well, are things that they all need to track and all start planning on how they're going to be part of it. So Dr. Sharif, thank you so much for letting me be a small part of the broadcast today.
Thank
Thank you,
you.
Sharif.
Thank you.
Thank you. Thank you, Dr. Sharif, for all the effort that
Thank,
you're doing.
thank you. Thank you. Thank you, Dr. Talib Rafal. Thank you, Professor David Smith. Thank you, our all of audience. I request all of our audience, please share our content with our government agency, corporation, and academy. Thank you. Bye-bye and take care.
Bye-bye. Bye-bye. Bye.
Bye-bye. Bye-bye. Yes.
Bye.